All right, so from A, we've got that we've got that t squared is c on A, and t therefore is plus or minus c on A. So t is, of course, we were talking about when x equals t. So let's put those into the y to find the y value so we can find the points. So when we put t equals square root of c on A into the y equation, we would get a times that squared. Remember, t is x. So we're going to get a times our c on A, because the a's cancel. We're going to get b times root c on A, and then c. So you can see we're going to get two lots of c's plus b root c on A when our t is positive root c on A. So I've got it over here. There's point B. There's root c on A as our x, and our y value is 2c plus b lots of root c on A. Same thing when I make t equal negative root c on A and put it in that y equation to find my y value. Y is a times, if I square that, negative becomes a positive, and I get c on A, and again the a's cancel, and then b lots of that, so that's minus b root c on A, and then plus c. So again I get two c's, but this time I get minus b root c on A, and you can see that just up here, two c's minus b root c on A for my y value. So in this part here, we're calling them points A and B. Let me just make room over here. I'll rub that out as well. So it's now talking about, if we look at this, I'll try and put that picture there as well. Here we go. So find the points A and B. There's my points A and B, where the tangents from the origin touch the curve. So we're talking about the tangents we'd already found, and show that the y-intercept, so C, is, so basically show that C is the midpoint of the interval joining the origin and the midpoint of the chord AB. All right, so it's talking about the chord AB. So let's pop a chord AB in. Okay, here's our chord AB. And so apparently the midpoint is here. So I haven't drawn it to scale. Now, midpoint AB, we know the midpoint of AB, is the average of our x's. So you can see we've got root c on A plus minus root c on A. So that's 0. So 0 divided by 2 is 0. So it's definitely on the y-axis, this midpoint. And then if I add the y's together, I've got a 2c and a 2c. That's 4c. And I've got plus b root c on A and minus b root c on A, which is 0. Now if I average those, I get just 2c. So that point there is 2c. That point there is 2c. Now, what we want to show, what did it say? Show that the y-intercept 0c is the midpoint of the interval. Well, of course, halfway between 0 and 2c is going to be c, and we know that c is the y-intercept of this parabola. So yes, 0c is the midpoint of the interval joining the origin and the midpoint AB, so that's nice. Now show also that the tangent at this y-intercept c, so let's draw a tangent there of the curve. So what colour haven't we used? Maybe yellow. So whoops, don't have a pen. So that tangent at the curve there we go. So we want to show that that tangent is parallel to that chord. Well, let's have a look at the chord first, since we're looking at the chord first. And the chord is in red. So let's find the gradient of AB, which we know is just rise on run. So rise is y2 minus y1. So what's our y2? Let's say 2c plus b root c on A, y2 minus y1, 2c minus b root c on A, on x2 minus x1 minus root c on A. So you can see we're going to get, the two c's are going to cancel. You've got a 2c and a minus 2c, so they're cancelling. And you're going to get, this is a minus minus, so positive. So you can get 2 of those b root c on a's. And on the bottom, again, minus minus, so plus, you're going to get 2 of those root c on a's. So great, the root c on a's cancel, the 2's cancel, you get a gradient of b. All right, so what about our gradient of our curve? We did do it in the first question. However, it's okay, we'll just do it again. All right, so I've got my curve up here. If I want my gradient function, I would just differentiate that. And then where do I want it at? I want the gradient when x is 0, right? At point C, the x value is 0. So if I put 0 in, of course, that first term just becomes 0, and I get left with a b. So the gradient at that point right there of the tangent, that gradient is also b. So we've got b, and the gradient of the chord AB is b. So those gradients equal each other. So the tangent at the y-intercept C is parallel. So those gradients, I could call them M1 and M2, they're equal, so they're parallel.